My name is Sebastian. Everyone calls me Sebi. Today I'm going to be talking about lessons learned from over 300 security audits. Just a bit about myself because probably no one has any idea who I am. Working in security since 2011, so I have around 10 years experience. And I've been at big companies, but I'm having a blast at Quantstamp. Really like the atmosphere in this space, super innovative, fast-paced. That's enough about me. About the talk. Over almost 4 years now, we've done 307 audits completed. And through those audits, we found a total of 2,445 issues. And you can see on this slide, they've been broken up according to their severity level. It's pretty normal that the high severity issues are less than medium, low, or informational. Interestingly, the undetermined issues are some things that we weren't able to judge how severe it is due to lack of documentation, for instance, right? We didn't know how bad it could be. So we marked it as undetermined, and we were expecting the teams to tell us it's high, it's medium, it's low. Sometimes that happened, but for these 283, it didn't happen. But interestingly enough, you're going to see that many of them were fixed, more than the informational or close to the low ones, right? So here it shows, this chart shows that 87% of the high issues were solved, which is good. Everyone wants to solve the high issues. Less and less issues are solved as you go down to informational level. But now it gets more interesting when you see the undetermined issues. So there were several cases where these undetermined issues were actually high severity or medium severity. So first piece of advice, don't ignore the undetermined severity levels. They don't mean that they're not important. Here's the same chart showing the absolute values. So ideally, all of these bars would be this reddish color, which would mean that everything has been fixed. But no, as you saw the percentages on the previous slide, certain percentages are fixed, certain not. But it's interesting to see this. So given these stats, how many audits do you think out of our 307 had all issues fixed? 0, yeah. 0 had all issues fixed. Here I just added some histograms of how many issues are unfixed according to their severity levels and then also the total. So you can see here, basically, if you sum up all of these bars, you get to 307. So out of the 307 audits, somewhere around 80 had one unresolved issue, okay? Then around 50 had 2 unresolved issues, and so on, right? And there at the far right, you can see an audit or a few which had 28 unresolved issues, right? So given all this information, bear in mind that if someone says that our project has been audited, it doesn't mean that that project is secure, okay? And I also like to quote this saying from Dijkstra. He says, program testing can only be used to show the presence of bugs, but not to show their absence. So, yeah, take claims from projects that have been audited with a grain of salt. Look at the audit report, okay? Moving forward, so what can you do, right? Is it game over? Is everything unsecure? No, but what can you do, right? You could use defense in depth. So here, I'm going to walk through each of these layers. So defense in depth is basically a methodology to add multiple layers of protection and not just rely on one. Many projects, they do a security audit and that's it. Other projects just do a bug bounty and that's it. You should you should use multiple things, right, to help your security. And yeah, if one of the layers fail, then the others could help protect. Here at the bottom, I'm showing the crown jewels. Basically, those are the assets that you have in your contract that you want to protect. And we'll be going through these layers one by one, starting at the top. First layer, develop using best practices. Oops. So here we have two steps. First one is the process, and the second one is the coding. For the process, it's not very different from any other classical software project, right? You should have great documentation, right? That means that you can start simple. You can start from user stories and derive functional and non-functional requirements, which are crucial for audits. You should draw diagrams, whatever you prefer, just to help the auditors understand how you imagine the project working. You should also have code comments. These are missing quite often. So have comments either or at the beginning of your function, inline, however you prefer, but have them. And last but not least, in documentation, you should have a description of all the roles, all the stakeholders, and what they're they should be allowed to do and what not, right? Regarding the process, there's a few more things here. So pull requests, you should have like peer reviews and not just like one developer merging into master every time, right? Each new feature, merge into master, right? That creates a lot of potential for bugs. Other than that, you should have tests. For each pull request, don't just add the code for the functionality. Also add tests, right? Should be careful because if you just keep adding code, at the end, you're going to be so psyched to launch that you're not going to write any tests. And you should also make sure that the dependencies that you're testing with, right? A project runs over several months. So when you start developing, you set up your platform, you do npm, yarn install, whatever, you download those versions which are at that point set, right? And if you don't update them in the process and you keep testing with those old ones, like maybe half a year later when you actually deploy on chain, those versions will be different and the behavior might be different. Now, I don't have a good example off the top of my head of some project that got like totally destroyed because of that, but it might happen, right? Finally, here on this slide, this is super important. We see this a lot when we audit. You should fork a secure version, right? We get a lot of audits where it's just a diff between some very well-known project and their code, right? And yeah, that project is well-known. It's been audited a bunch of times. But the commit that we're given that is forked from has not been audited. It might be even like it was susceptible to a hack, right, which was published. But the developers didn't know at the time, right? They might not be security savvy. They might have not looked at when the hack happened, right? So it happened that someone forked and built on top of something which was hacked, right? So be careful with that. Regarding coding, this is a list taken from the CMU CERT website. And you can see how well it applies to coding in this space as well, right? Basically, the biggest culprit, validating untrusted inputs and data sources, right? That means malicious users, don't trust the users that they're going to give you good input. Even if they're admins, right? They might mistype something, right? And that's a problem. So you should always validate. Also data sources like oracles, right? You should check if the output of oracles are as expected. Compiler warnings. This is something which is oftentimes totally ignored, right? We sometimes build projects that we are auditing to run the tests, do dynamic analysis, and it's full of compiler warnings, which like off the top of the bat, like raise some findings, right? So these things are something that you should fix immediately. When you're building, if you see compiler warnings, fix them. Another important one, access control, right? There's so many hacks, right? The parity wallet hack, right? Due to poor access control, right? Other tons of hacks due to this kind of thing. So you should carefully design this. And where do you start? Well, you start with that documentation about what each role should do and what shouldn't do, right? Then you can design a proper access control policy. The fourth one is in italics because it's quite interesting. So in classical security, it's default deny, right? But in typical Solidity, it's default grant, right? When you write a function, anyone can call it. You need to explicitly write a modifier or introduce a condition which is not going to allow anyone to be able to call that function, right? So it's tricky because the default in Solidity is allow, right? So you need to be careful to add these modifiers to each function that needs it. Fifth one, and my personal favorite, keep it simple. So there's plenty of cool patterns in this space, right? The diamond pattern, super cool, but really hard to audit. So if you can do a project which is quite simple in a way which requires 2 Solidity files, don't use the diamond pattern instead, right? Because maybe it's going to give you headaches if you don't plan on using the full power of that standard, right? Sixth one, you need to give your roles, again going back to the roles, the least privilege, right? So you shouldn't allow admins to do absolutely everything that other roles do because they're admins and they're trusted, right? An admin's key could be stolen. We've seen a lot of rug pulls lately. So if the admin doesn't need to do magical stuff, just leave them like the basic stuff that they need to do. And let governance or other roles do stuff like, which is harmful to end users. 7, you should sanitize output data. This means, again, going back, this is one of the biggest problems that we see today with DeFi composability, right? You see a lot of projects working, interacting with each other, building on top of each other, and using those projects as like, yeah, this is going to give me exactly what I want, right? But then, surprise, surprise, you call, I don't know, swap on Uniswap v2, and you get a way lower value than you actually wanted to get for that swap, right? Or you call some, whatever, DeFi, you have a DeFi yield aggregator, and you're calling all sorts of DeFi projects, and you're not getting back the amount that you want for the shares that you're minting, right? So be careful with sanitizing outputs, and don't assume that you're going to get the right amount always. Defense in depth, we're talking about right now. We're at layer 1, still layers to come. Use that, and it's pretty good. Number 9, testing. So have unit tests, have integration tests, and most importantly, mainnet forking tests, right? You should be able to test your project on the real network. Last but not least, define security requirements and model the threats. If you're not experienced in that, contact an auditing firm. They're going to help you. They're going to be happy that you came to them early and you're able to model threats at an early stage. Second layer, automated scanning and testing. Here you leverage the power of continuous integration systems. So basically, these systems allow you to automate a lot of things that you should be checking. So first thing, the tests, the things that you've been writing all the time. Make sure that when you add a new feature, all the tests pass, and you're not allowed to merge otherwise, okay? You should also compute coverage and mandate that something like branch coverage using a tool like Solidity coverage is always above 90%. Run static code analyzers, right? There's plenty of them. They're really good. They have a lot of false positives, but still, you can have someone mark things as false positives and be sure that you haven't missed stuff, okay? Also, linters are important, right? If you want to have a smooth audit, you shouldn't have your code all over the place in different styles and so on. So linters play a good role there. If you do all of this before you start an audit, your auditors are going to be really happy and the process is going to be much smoother. I want to stress this a lot. This is something that should be done much more in this space, testing. It's so sad when we get projects which have 0 tests, okay? Always test the extreme cases when you're integrating. Question, can Compound run out of liquidity? Yeah, it can. So write tests which take that into account. You don't want your project to explode if that happens. Same thing on the previous slide, fork testing. Do mainnet fork testing. That's going to help you test on the real environment. And just an example of things that could go wrong, number of decimal issues, right? This is like very common nowadays, surprisingly. It's because mock tokens, they're vanilla tokens. They always use 18 decimals, right? If you don't have someone who's like very eager to change the mock values, like the default values, they have 18 decimals, and then when you try it with wrap Bitcoin, surprise, it doesn't have 18 decimals, and you're gonna like transfer more Bitcoin than exists. Also, you might have tests with just a subset, like everyone might want to test with DAI or wrapped Ether. Again, those have 18 decimals, right? If you want to test with subset, test with those tokens which are interesting, right? USDC, USDT, they have different behaviors. They're gonna break some stuff if there are like issues in your code. Same thing as we talked about before. You should document what the parties can do and cannot do and test the negative cases. If you're saying the admin should be allowed to transfer whatever, test if a non-admin user can transfer that amount, right? Code coverage is not the main thing in testing, okay? Like, we've seen test suites which have 100% branch coverage across the board. They're just unit tests which just aim to maximize code coverage. They have 0 assertions, right? So if you have like 100% coverage with 0 assertions, it's useless. So check the quality of the tests, the assert statements, assumptions, right? Make the assumptions explicit. Like if you have assumptions like, okay, this test should only run in those conditions, make that explicit and the auditors will tell you if that's realistic or not. Cool. Okay, I'm getting to the core of the talk with the lessons learned. So this is where all those lessons learned are. And first question, who here has gotten a security audit? Okay. And who wants to get one? Awesome. Okay. This part is focused for you. So the process that we use at Quantstamp is first you're contacted by an auditing firm, or you contact the auditing firm. You share the quote. You ask for you share the code and you ask for a quote. The auditors are going to scope it and send you the quote. The audit is performed. The report is delivered. Afterwards, you have time to discuss the report and implement the fixes. After the fixes are implemented, the re-audit is performed and the final report is issued. Now, we're going to go through lessons learned in each of these parts because the process is quite simple, but there's a lot of, like, the devil is in the details. Before we go into that, I wanted to give you like an idea of how the space has evolved over the years. Like when we started in 2017, there were just ERC20 audits. In 2018, started seeing the first DeFi primitives in addition to those ERC20 audits. 2019, much more DeFi. We saw also a bunch of bridges, really diverse 2019, I would say. 2020, DeFi summer, a lot of NFT projects as well, really exciting. But complexity grows, right? And this year, we're seeing like massive complexity with all this composability, with cross-chain DeFi, it's quite overwhelming, given that there's so little documentation and testing. So lessons learned while scoping. The first phase, right? First, decide what you want. If you want a high-level review, a manual audit, formal verification, wherever you want, just decide on it, contact the firm. Ideally, the code that they scope is going to be the same that has been audited, right? There have been cases where we're contacted to scope something, and when we get to audit that thing, it's like double the size or even more. So that is not cool. And it's going to lead to delays and everything because we haven't planned for that much capacity, right? You should also set up a call, a scoping call, right? Where you tell the auditors, here's our tech stack, here's the repo structure, these files are most important. We're really afraid of those files because the developer was on vacation when he wrote them. Show them if you have like a setup, right? If you have like a test network, or it's deployed on a test network. Give them documentation, but don't overwhelm them, right? We had an audit where we were given like 100 white papers, and that was a bit too much. But like, don't like give them something. And also set the expectations, like what's your timeline? When do you want to launch? When do you think you're going to have time for fixes? And so on, right? Those are the things that you can do on the scoping call really early. You figure out if that's the right company to audit your project. Here's something which I computed based on the data which we have at Quantstamp. It shows the number of auditors on the x-axis and the number of issues found during that audit on the y-axis. And the reason why I wanted to plot this, just to see what the trend in number of issues found is. So, not surprising, the more auditors you put on an audit, the more issues you find. Of course, there's exceptions here, right? But like, some projects are really good, so it's hard to find issues in them, right? They probably use defense in depth. I heard it's good. So in addition to that, what can you do? You shouldn't try to save by having fewer auditors, because that's just going to mean that you find fewer things. You also should make sure that the backgrounds of your auditors are diverse, because what we've noticed is that at Quantstamp we have like auditors with like trading backgrounds who are quant traders. We have people who've been in the security field for a long time. We have developers which have been at top companies, right? And if we mix, we also have academics, right? And if we mix all of those, it's going to lead to an awesome report. There's so many different issues, right? The quant traders, they're going to look at all the financial modeling there. The security guys are going to look at all the like language-specific issues and everything like that. Academics, they even try like really fancy stuff that has been recently published. So it's really good to have diverse backgrounds of auditors. Don't try to speed things up by asking to audit just a diff, because sometimes even a one-line change could lead to a huge hack, right? This happened this year, okay? One line might be super important. If you just look at that line, you're going to miss it. You need to look at the whole thing. You need to make sure that your auditors have the necessary background to audit that diff. Also, don't wait until the last minute, okay? It's good to plan these audits in advance, because if you do it last minute and the auditors have given you a smaller scope because they weren't underestimating your project due to lack of documentation, it might lead to delays, right? Because they need more time. Or if the things that they find are very hard to fix, that might also lead to delays, right? So make sure that you're either flexible in when you launch or do the audit well in advance. During the auditing phase, this is pretty easy. When you start the audit, make sure that documentation is ready. End user documentation is often ready because it's close to launch. But these other things, technical documentation, interactions, the math formulas, those are often missing, and it's really hard to figure out if the implementation is correct without that information. I think without this information, without these kind of technical documentations in math form, you can't even do formal verification, right? You need to know what the system is supposed to do. You should also have comments. These speed up the auditing process a lot. If you don't have comments, the auditing process is going to be 2 times slower, okay? Also, do a deep dive or a walkthrough with the auditors when they start and record the video. The auditors are going to keep watching that, trying to find subtleties. We use this a lot. It helps. Also, shared communication channel right from the bat, right off the bat. So answer questions as soon as possible and politely. If you don't answer politely, don't be surprised if they give you the cold shoulder or like are afraid to ask, right? Say like, oh, that's a stupid question, then probably no one will ask anything anymore. And this one is super important for re-audits, right? Like during the fixes, right? Don't make code changes while the audit is in progress. That's going to lead to problems during this period. When you get the report and you read the report, it often happens that you say, well, these are not high severity issues. These are, I know these things. I don't care about them, right? So we see a lot of issues being dismissed because the attacker's not going to exploit this. Come on, the attacker doesn't care about griefing attacks, right? Who performs griefing attacks? Why would they do that? Well, it turns out that they do, right? And anything, like auditors report anything that is strange, fishy, right? So have a discussion with them. Like ask them, like, what do you think would be the scenario? Why would an attacker do that? Also pay attention if the auditors mention documentation issues and test issues. Often these things are totally ignored during audits or the re-auditing period. So it's really good to pay attention to those and fix those. During the fixes, when you're addressing the findings, you should ask for a re-audit guide. We have a great re-audit guide. Basically walks the customer through what they should do, right? Some things which are important is open a separate pull request when fixing each issue. Don't mix everything together, right? You should know, like the auditors should be able to see how they are fixed, how each issue is fixed and not everything together. But of course, you should also merge everything together so that they can take a look at the ensemble, right? Because if like some fix might invalidate another fix, right? Provide argumentation why certain issues are fixed and why others are ignored, and also mitigated, right? You might not want to fix an issue because you have a way to mitigate it, which is lower cost, and you're willing to accept part of the risk. Do not add extra features with the fixes. Like sometimes, like some people sneak them in, you know, like, come on, it's just a small feature. It's like nothing. Don't do that. It's going to lead to delays. And avoid refactoring. Like we've had these problems. When we get the re-audit, the things have been fixed, but like the code has been renamed, files have been renamed, everything has been realigned because the linter has finally been used. And that creates really big difficulties when looking at the fixes, right? You're like, what am I looking at? Like, of course, like there's tools to help you with that, but it wastes time. Add the missing documentation and test issues that were signaled. That is going to help the re-audit because sometimes when the documentation has been fixed during the re-audit, other issues which are more important might come up. Those undetermined issues that we talked about in the beginning, they become clear that they're high severity, medium, low, or informational. That's super important. Super important on this slide is that you should also fix as soon as possible. Don't wait too long because auditors have a mental model of your project, and if you wait too long and you give them the re-audit after a month or two, they won't remember anything about your project, right? So it's like they're going to take 5 times as long to re-audit just to remember what they were talking about, when, like what your project was about. And the last step, when you're finished, when the the final certificate has been issued, it's cool to ask the auditing firm to publish this as a neutral third party so that your community doesn't say, oh, but maybe you've tampered with the audit report and you've marked everything as fixed. How do we know that you didn't do that, right? If you ask the auditor to publish this, those kind of rumors might go away. And also, social media helps to spread the word, right? Most importantly on this slide, point number 3 here, make sure that the code you deploy on chain is the same as the one that has been audited. Because if not, that one line could cost you like a lot of funds. Monitoring, the 4th layer. Here, you basically should define a strategy, how you're going to respond. You should have some monitoring in place, alerting in place. And once you get an alert, like we sometimes see projects, they have monitoring in place, it's awesome, it catches everything, but they have absolutely no strategy how to deal with them, right? A hack happens, what do we do, right? What should you do? Like, depends when the issue was found. If it's found by an internal team, extending the project or whatever, you have maybe plenty of time to fix it until a malicious attacker finds it. But if it's a bug bounty, you might not have enough time, right? 90 days to responsible disclosure, then they can publish it. Or if it's an exploit of a live system, like how do you immediately react to reduce the impact of the hack, right? You should have some kind of alerting in place and a process. So you should respond to incidents collaboratively together with your auditors. That shared channel that you set up during the audit, use that, send the auditors the transaction which is fishy, and ask them, hey guys, can you help? They're going to help you find the root cause, find a way to maybe mitigate, reduce, like stop the attacker from exploiting, and also to fix, right? We've done this successfully with plenty of our customers. Also, perfect your post-incident response during reviews, right? If it didn't work out the way you imagined it when you responded to some incident, figure out an improvement of the strategy to make it smoother next time. Finally, you can employ, there's a bunch of automated tools, right, that can do this. And here I'm just posting a picture of our Quantstamp monitoring service, which is deployed in production, used by Binance to monitor plenty of contracts. Last layer of defense, insurance. This is an exciting one. If everything else fails, make sure you're covered, right? These are the layers, right? So you have quite some space to maneuver here. This area is quite new, and they offer a bunch of different configurations, right? You could have a B2B policy where you as a project, you go to an insurer and say, I want coverage of 80% of my AUM, right? If the project gets hacked, you're responsible for giving back your end users the funds that have been lost. But you could also like say, oh, that's too big of a headache. I don't want to be involved in that kind of stuff. So do a B2C, where the insurer directly is responsible for allowing end users to file claims and to get their insurance back. You can choose between crypto native and traditional. Crypto native, there's a bunch of projects out there, very cool, very nice ideas. There's also like traditional insurers which are starting to dip their toes, right, into the space. Not so strongly in DeFi, but other spaces definitely, and DeFi is definitely up and coming for traditional insurers as well. You have companies such as Aon and Lloyd's who have been dipping their toes for like more than a year now in this. Maybe have a combo, because in crypto native ones, we've seen hacks, right? And then there's the question, who insures the insurer, right? If your insurance pool is hacked and drained, you might be left holding the bag. Also, decide if you want an automated trigger for claims or a manual trigger, right? We know projects which have a manual trigger where there's a committee, some experts decide this was a hack which was exploiting a 0-day and it was covered by the policy or not. Or there's projects which are up and coming which have an automated trigger which don't need any decisions from human experts. Also, try to tailor your policy as much as possible. Try to make sure that you know what you're covered for. Many projects might expect that they're covered for everything, right? Like, if someone buys insurance, I'm insured, I'm fine, right? But if like a reordering attack happens, right? Or something like maybe at the layer 1 level, right? That's what I'm talking about. That's not covered, right? You check out the policies, those things are not covered. You should also you try to reduce the premium. The more security layers you have, the smaller your premium is because your risk is lower. In conclusion, just wanted to say that defense in depth is something that you should use. I like to do this parallel with avoiding COVID, and the best practices and the development best practices are like wearing a mask and social distancing, right? They're effective, but you can do more. Automated scanning and testing is like PCR testing. Audits are like the vaccine. They're like 90% effective. Monitoring and incident response is like temperature measurement or other stuff. And insurance is like if everything fails, I got sick, you need some treatment. That's it from my side. Thank you for your attention. Any questions, or do we have time? Yeah, right. Oh, awesome.
Hey, in the beginning, you're going over risk levels from high to low and informational. How do you quantify risk? Like, what do you consider high versus low and medium? Like, what's the categories in this?
Yeah, that's a very good question. Thank you. So, basically, we have human readable definitions about, like, in our audit report, about what it means to be high, and it generally involves something which is exploitable by an external party with no privileges and can have a high financial or reputational damage. The medium one has lower damage. The lower one is probably hard to exploit, maybe by privileged users. Informational ones are very hard to exploit, okay? These are like, they're easy to understand by non-technical users, right? And I would say like the community is pretty technical, but there are definitely non-technical users who need these kind of descriptions. From a technical perspective, when we internally decide, we also look at impact and likelihood, right? There's this matrix which has impact, likelihood, and you basically multiply those things, right, to decide what the severity is. Does that answer your question? Yep. Awesome. Any other questions? Don't be shy. Awesome. If you want to read more about Quantstamp and what we're doing, please visit our blogs. We do a lot of cool stuff. Oh, there's another question? Yeah. Awesome.
What do you handle audits within Quantstamp? Oh, sorry. Can you hear me? Is it better?
Now I can hear you, yeah.
Yeah, okay. How do you handle like the audit within Quantstamp? I mean, what's the process, if you can say?
Sure, sure. So what we do is, it's similar to what you've seen here, right? This line here. You're talking about just this phase, or because like we first always scope it. Mm-hmm. We assign auditors which are best suited for that particular tech stack and project. So like if it's an NFT project, we have some people who have a lot of experience and passion for NFTs. If it's a DeFi project, depends if it's a yield aggregator. We take the guys who've done a lot of yield aggregators, put them on that, right? We try to combine that to make this diversity, like have a quant trader, have a security expert, have a very good developer, because that's how we're going to maximize the efficiency, the things which were found. And we assign these guys if we need more than, like sometimes the project is big, right? We need more than 3 auditors, right? The default is 3. We need more, we're assigning more, we're planning for it in advance. We're planning like probably a month in advance when it's going to be done. What's the deadline? We communicate it to the customer, If they agree, that's great. When we start, we do all of those things which are mentioned there. We ask for code walkthroughs. We try to understand how the project works using the documentation or the walkthrough. And then we, like, once we understood it, we dig into the code. So we don't really jump into the code without understanding what the thing is supposed to do, right? And many times we talk a lot with our customers via those shared communication channels. So we ask them questions like, did you guys intend to do this here because it's not documented, right? Those kind of questions we ask them a lot. We have long conversations. Maybe we have another meeting if necessary to the code walkthrough. And at the end, everyone does it independently. We don't have a pool where everyone puts their notes. Every auditor does it independently. We're highly distributed, so we're not like necessarily people in the same office. At the end, when the internal deadline is there, the audit lead collects all the notes, comments if anything is unclear, and then puts everything into an audit report. That audit report is reviewed by all the other auditors, and there's discussions on how severe is that issue. Is it really high severity or is it medium, right? We change these things according to these discussions, and we might also add or remove issues if we think like we missed something or if there's a false positive.
Okay, last question. And what is the process to the auditing process? I mean, you print the code and try with like a pen to find
I can't hear you.
Okay. It's better. What's the auditing process, in fact? Do you print the code? And,
you mean like for each auditor?
With a pen. Yeah, for each auditor. Do you have like a kind of framework and that every auditors follow?
Oh, yeah. And so we have an internal checklist of things that you shouldn't forget to check, right? But we often go off script. So each auditor goes through the code line by line. We don't run the tools at the beginning. Only the audit lead runs tools at the end when everything has been compiled, because we don't want to get biased, okay? So we go through the code line by line, and we look at the checklist, remember things that we need to check. But like I said, more often than not, we just like, each project is very specific in its own way, right? So maybe there's things on that checklist which, like there's things missing, right? So we sort of like go down the rabbit hole and find very specific bugs to those projects, which are like according to their business logic or something like that. Does that make sense?
Yeah, totally. Thank you.
Thank you. Awesome. Thank you for your attention. Have a great conference.
Thank you.